So example 6 says an airplane is flying on a flight path that will take it directly over a radar tracking station as shown in the figure. The distance S is decreasing at a rate of 400 miles per hour when S is equal to 25. Part A says, what is the speed of the plane? So first thing that you should do on all of these is to write down what you know. So the distance S is decreasing at a rate of 400 miles per hour. So that is a rate of change. So one thing that I know is that ds dt is equal to, and since it's decreasing, I'm going to make the rate negative. So I know that ds dt is equal to negative 400. Tell me one other thing that I know. I know that S is 25, all right? So my hypotenuse here is 25. And look, I've got a Pythagorean triple. This is 7. The hypotenuse is 25, so X is
14, 15.
Well, we are a bit rusty on our Pythagorean triples, right? So get out your calculators, I guess. So much for that number sense. Competition.
49 plus.
Oh my goodness, please get out your calculator. You're going to need it anyway, so you might as well get it out. It is not. Woo, we are on a number sense roll.
22. Where it has to be less.
It can be bigger than the hypotenuse, right? It's 24. Okay. This is what I know. I am trying to find the speed of the plane. So this is going to be the rate of change of the x variable here. So I want to find dx dt. And so I am going to write an equation relating all of these things together, namely the Pythagorean theorem. So I can do this. I'm going to write 7 squared, 7 squared plus x squared is equal to s squared. And so I can plug in 7 already because, why can't I plug it in? It is given, but it is a constant. So notice, if the plane is flying at the same altitude, then this 7 miles will not change. And I can plug it in because when I take the derivative of a rate of change that does not change, that derivative would be 0. Right? So that is going to go away. Anything that does change, remember, I said that we cannot plug it in until after we differentiate. However, the 7 is going to go away because if I were, let's say that I were to call this y, right? If I were to tag it with the dy dt, that would be 0 because the plane is flying at a constant altitude. Okay, so that goes away. And now I'm going to differentiate. So the derivative of x squared is
2x dx.
I gotta tag it. So it is 2x dx dt. And the derivative of s squared would be 2s ds dt. Tag your variables. And so now I'm going to simplify my life and divide both terms by 2 to get rid of the 2's. And I'm going to plug in what I know. X was 24. Dx dt is what we were looking for. S was 25. and ds dt was negative 400. So solving for dx dt, go ahead and take your little calculator and work that out, please. And what do we get? Somebody help me. Point what?
0.6 repeating.
Well, I don't think we want the mark of the beast in our calculus notes, so
0.66.
we're gonna
Seven.
round. We're gonna round. No mark of the beast in the calculus notes. How about 667? Mhm. However, this is not the correct answer. Okay. Why is it not the correct answer? They asked me for the speed, and speed is it positive? Did I drive negative 60 miles per hour on the way to school this morning? I did not. Speed is the, I'm waiting for somebody to say, it's the absolute value of the velocity, coach. Go ahead, Jackson, that was your
It's
cue.
the absolute.
It's the absolute value of the velocity.
Yeah, that's it.
Therefore, the correct answer is 416.667. And let's put some units on there. The plane is traveling 416.667 miles per hour.
How did you know at the very beginning that the equation, like the 7 squared plus x squared? Like, where did you get that equation from?
From the picture here, I use the Pythagorean theorem to relate all of these variables together.
But how would that give you speed when all of those are just like distances?
Because whenever I take the derivative, that is giving me the rate of change of those distances. Does that make sense? So it's kind of like in physics, if you have a position function, which is a distance, and you take the derivative of that, you're going to have a velocity, which is a rate of change. Let me make just one other comment here. If this were a multiple choice question, those dirty little rotten scoundrels on the AP exam would probably have a positive answer and a negative answer with a distractor, right? So that half of you would fall prey to their shenanigans and do all of this great math and get the wrong answer because that one last little thing, you forgot that speed is the absolute value of the velocity. Okay, so I guess what I'm saying is be careful, right? Because we want to get credit for things that we know how to do. Questions on this part? Yes. The 7 squared cancels because if the plane is flying at a constant altitude, does that change? Since the 7 miles does not change, the rate of change of that is 0 whenever I differentiate. So in other words, the 7 is a constant. I can plug that in and it's going to go away because there is no rate of change since the plane is flying at a constant altitude. That makes sense? Okay, so part B says, at what rate is the angle of elevation of the plane from the tracking station changing at that moment? Oh, excellent. An angle of elevation problem, remember? Sorry, you probably don't remember that from geometry, right? This right here, we're gonna call it theta. So this is the angle of elevation. And I want to find the rate of change of this angle of elevation. So this would be find d theta dt. So let me draw a little picture. Well, we already have one. This is theta. This was 7. I'm gonna call this X and this S. I need an equation that relates all of these variables. What do you say? How about a little SOHCAHTOA? Let's do tangent. You gonna do that? Tangent of theta. So the tangent of theta would be equal to SOHCAHTOA opposite over adjacent, so x over 7. You could do another trig function also, that would work. The math would work just as long as you know all of the values and the rates of change of those values also when we
Why
tackle.
don't you include 25?
All right, well, I guess we need to do a little calculus. We need to take the derivative. What's the derivative of tangent of theta?
Yours right.
I'm okay with awkward silences. Are you? Maybe the people watching the video aren't, but haven't heard what are we looking for? What are we trying to find? D theta dt, right? So we might get stuck if we forget to tag our variables. So the derivative of tangent of theta is not just secant squared of theta. It's what? Secant squared theta d theta dt. How about that? And now I need to take the derivative of the other side. I'm going to write this as 1 over 7x. You like that? So what's the derivative of 1/7 x? It's just going to be 1/7, but I need to tag it. So I need a dx dt. All right, well, I'm missing a couple of variables. Dx dt, I just found, it's right there, so we're good. D theta dt is what I'm looking for, so it's okay to be missing that. I do need theta, however, so we need to find theta. How about we go back to this right here, and we do tangent of theta is going to be opposite over adjacent, so 24 over 7. So take your little calculator. And do we know how to solve for theta? Here on our calculator. I hope so, right? It's second tangent 24 divided by 7. And you should get 1.287 there. Okay. So theta, go away. So theta is equal to 1.287. All right, so let's write down what I know here. I have secant squared of theta, and theta is 1.287. And that's equal to 1 over 7 dx dt, and dx dt is negative 416.667. And so, oh, I left off. I'm pretty disappointed. Nobody told me. Where's your d theta dt, Newhouse? That was your cue, Jackson. Shirking your duties there. I've got to have a d theta dt in there. That's equal to 1 over 7. Now we are in business. I need to solve for d theta dt. So I'm going to divide by secant squared of 1.287. So let's see, we got d theta dt is equal to 1 over 7 times negative 416.667. And then I'm going to divide by secant squared of 1.287 on both sides. And I could rewrite the secant squared to help me out a little bit. I'm going to write it as 1 over secant squared is cosine squared. So I could write this as cosine of 1.287 squared. So now take your calculator and let's find d theta dt. Oh, everybody get their calculator and work it out. And my answer has to be negative, right? Because the angle of elevation is decreasing because the plane is getting closer to the tracking station, right? It has to be negative. Somebody plug those in and tell me what you get.
I got negative 59.464.
Check that. I got something different.
What, negative 4.667?
That's what I got. I got negative 4.667.
Yeah, that's what I got.
And let's put some units on there. Theta is measured in, we are always in radians in calculus, right? So radians and time in this instance is measured in hours, I believe. So we got negative 4.667 radians per hour is the rate of change of theta, where theta is the angle of elevation. Okay, so let me pause there for a second. Any questions for me that I can answer before we move on to the last example? All right, here we go. Example 7. Water drains from the conical tank shown in the following diagram at a rate of 5 cubic feet per minute. The radius of the cone is 4 and the height of the cone is 10 feet. So let me draw a little picture. We got a radius, that's 4. We got the height over here, which is 10. And part A says, what is the relation between the variables h and r? I'm going to go ahead and work that part of the problem before we write down what we know and what we're trying to find. I can write a ratio for the radius and the height. I'm going to say r over h is equal to 4/10. And then I'm going to solve one of the variables in terms of the other. So if I cross multiply here, I get 10r equals 4h. And then I'm going to solve for r. So r is equal to 4/10. Or I could write that simplifying the fraction. R is equal to 2/5 h. There. All right. All it did was set up a ratio and then solve one variable in terms of the other. Okay, so let's write down what we know. What is this 5 here? I'm going to pay attention to the units. It's 5 cubic feet per minute, and it's a rate of change. So it's the rate of change of what? Of the volume. So I know that dV dt. I also know that the volume is, if the water's draining, is the volume, then the water, if the water is draining, then the volume of the cone is obviously decreasing, okay, because the water is going out. So dV dt is going to be -5 in this instance. I also know that h is going to be 6, and they want to find how fast the water level is dropping. So that is a rate of change. Also, what is it a rate of change of? It's not the volume because I just wrote down what that was. It's the rate of change of the height. So I want to find dH dt when h equals 6. And so I need an equation that will relate all of these things, and I would give you this equation, right? The volume of a cone. Volume is going to be 1/3 pi r squared h. Pi r squared gives me the circle. Then we have the height, and it's 1/3 because it's a cone. Everybody follow me okay so far? Okay, so if I am thinking through this problem, I hope that you do this, right? If I am thinking through this problem, I'm going to do the product rule right here between my two variables. And whenever I do the product rule, I'm going to tag both of my variables. So I'm going to end up with a dr dt and a dh dt. And that is a problem because dH dt is what I'm looking for. So it's okay if I don't know that, but I don't know, based on the information that they give me, I don't know what dr dt is. Correct? They don't give me that information. And so whenever I do the product rule and I have a dr dt, I'm going to get stuck. So I'm going to do a little, shall we say, calculus hoodoo voodoo here and manipulate my equation so that I can differentiate it. So what I'm going to do is, this is why I asked you to write the relation between h and r at the beginning. I'm going to take 2/5 h and substitute it in for r because they are equivalent. And then I'm only going to have one variable. So I got volume equals 1/3 pi, and I know that r is equal to 2/5 h, and then that's squared, and then it's multiplied by another h. So let's clean this up a little bit. I've got volume equals 1/3 pi, and then I'm going to square this. 2/5 squared is 4/25, and h squared times another h. And so I'm going to write this as volume equals 1/3 pi. And then I've got 4/25 h to the third, h squared times h. And I still haven't differentiated yet. I just substituted 2/5 h in for r so that I could get rid of that r variable. Everybody okay? So now I need to take the derivative. So derivative of v is going to be dv dt. I'm going to do the product rule here. So I've got 1/3 pi times the derivative of 4/25 h cubed. So I'm going to multiply the exponent 3 times the coefficient, 4/25. So 3 times 4/25 is 12/25 h, and I decrease it by 1 to give me squared, and then I don't forget to tag the variable. So I need a dH dt. And then, of course, the second half of the product rule, the derivative of 1/3 pi is just 0, so I'm going to ignore that. And now I am in business because I can plug in what I am missing and solve for dH dt. So dv dt is -5. And I've got 12/25, and h, careful, they asked me to evaluate h, or excuse me, they asked me to find dH dt when h is 6. So I'm going to plug in 36 for h squared, and then dH dt is what I'm trying to find. So now take your calculator and solve for dH dt. It has to be negative again, right? Because the height is decreasing as the water drains out. Plug those values into your calculator and solve for dHdt. And someone help me out. What do we get for dHdt? Negative 0.276, and the height is measured in feet, I believe. And the time is measured in minutes. And that makes sense in the context of the problem because the height is decreasing as the water drains out.